Welcome to the presentation on quadratic functions. Today we're going to learn about the algebraic form of quadratic functions and what quadratic functions look like graphically. So let's jump straight in and examine first off what a quadratic function is and what it looks like from an algebraic perspective. So the technical algebraic definition of a quadratic function is a function that appears like this. We have f of x equals ax squared plus bx plus c, where a is not equal to 0 and where a, b, and c are constants. A, b, and c are constants. Okay, so if you ever encounter a function where you have f of x equals and then a constant times x squared plus or minus a constant times b that's multiplied by an x, plus or minus another constant. So long as a is not equal to 0 here, so long as this value is not equal to 0, then we do have a quadratic function, and we can say with confidence that we're looking at a quadratic function. Now notice here that we could have written this as y equals ax squared plus bx plus c. And this would have represented the same function represented here. It's slightly different terminology, but it represents exactly the same concept. Notably, every quadratic function we'll examine in this section has the property that there are two x-intercepts. And if you don't know what that means, that's all right. You'll discover it later on. Pretty much it means that if we were to graph this quadratic function at 2 points, it would meet the x-axis and intersect with the x-axis. There are other quadratic functions, but we're going to examine those in other sections. So this is the algebraic form of quadratic functions. Let's go ahead and look at a few examples, and let's determine what a quadratic function is and what a quadratic function isn't. So our first example here, we'll call this example number 1. We've got y equals x squared minus 4x plus 4. So we should ask ourselves, does this suit the definition mounted above? Well, sure enough, it does. We've got 1 times x squared. That's the same as saying x squared. So here our a constant would be 1. We've got minus 4x. That means this b would be minus 4. We've got plus 4. So our c, our constant term here, would be equal to 4. So this is a quadratic function. It follows this form. What about number 2? We've got f of x equals x squared. Well, this is also a quadratic function. Here, b and c, these constants are equal to 0. And that's okay. We can have b and c equal to 0. We can't have a is equal to 0. And sure enough, x squared is like saying 1x squared. It's like putting a 1 out the front here. So here, a equals 1. It doesn't equal 0. Consequently, this is a quadratic function. What about this third example? Example here we have y equals minus x times x plus 4. Well, this might not initially look like a quadratic function because we can't see an x squared. But the key here is that we have to simplify it. This is a factored form. Let's simplify this. So minus x times x, that's going to be x times x is x squared, so this is going to be minus x squared. Then we're going to have minus x times 4, so this is going to be minus 4x. So this form, when we have minus x squared minus 4x, well, this looks very similar to this above. Here we have an a equals minus 1, and a b equals minus 4. So this is also a quadratic function. Okay, let's have a look at which functions are not quadratic. So here, we'll call this number 4, example 4. We've got y equals x cubed plus x squared plus 2x plus 4. Well, you'll note here that in this latter part, we have something resembling our definition, where we have an ax squared plus bx plus c, where a equals 1 and b equals 2 and c equals 4. However, we also have an x cubed out the front. And because we have this x cubed out the front, it doesn't resemble this definition completely. So this x cubed means that the presence of this x cubed in this equation means that this is not a quadratic function. What about example 5 here? Well, f of x equals 3x plus 1. Here we have a function where a equals 0. We've got no x squared term here. So we've got b equals 3 and c equals 1. But because we've got an a equals 0, we've got no x squared term here. it doesn't resemble a quadratic function. It's not a quadratic function because one of our stipulations is that a cannot equal 0. So if we ever have a quadratic function if we ever have a function that looks like this, we can actually determine that it's a linear function rather than a quadratic function. This function would be a straight line. What about example 6 here? Here we've got f of x equals 2 to the power of x plus x squared. Well, this x squared is nice. However, this 2 to the power of x, any function with 2 to the power of x is not a quadratic function because that's not specified in our algebraic definition. So that's the algebraic definition of a quadratic function. And you can clearly see which are quadratic and which aren't quadratic. Let's also examine the graphical representation of quadratic functions. And on this right-hand side, we have 2 quadratic functions that have been graphed. Now, this top quadratic function is in the shape of an upward opening parabola, like this. This type of quadratic function we call concave up. Concave up. Alternatively, the other type of quadratic function you could have is the one featured below here. So this is a downward opening parabola. Looks something like this. And this we call, unsurprisingly, a concave down quadratic function. Concave down. Concave up and concave down have quite strict mathematical and technical definitions, but for our purposes, this is all we really need to know at this point. So there'll be a more in-depth treatment of quadratic functions and their features in another video, but suffice to say that quadratic functions will always either look like this or they'll look like this. So they'll look like an upward opening U-shape or a downward opening upside down U-shape. For instance, we'll never get a quadratic function that, say, looks like a straight line. Or we'll never get a quadratic function that looks like this. Or a quadratic function that looks like this. In fact, this isn't even a function. So we'll never see quadratic functions look like this. Instead, they will always take this particular form, this upward opening or this downward opening, concave up or concave down form. So this has been a quick introduction to quadratic functions. Now you know how to identify quadratic functions from their algebraic form, and also you have an indication of what quadratic functions look like in a graphical form.